शांतिनी बोल.
Come on, everyone. Let's start off. Great. So last thing we have done with differentiation, and we did some applications of maxima, minima, and stuff. There's a lot more to that, but then again, that will become more max. So for us, for physics, we did what was sufficient. Great. So let's go ahead. With integration today. Again, integration, right? We'll be doing the mathematical part and few applications, but especially integration, right? We're going to use it a lot later on. I think mostly from fourth or fifth chapter, like work per energy or center of mass and stuff. So that's where we will use it extensively. And then when it comes again, I'll be taking up again. So let's go ahead with, so what's integration? So one thing is clear, so far if you have seen the whole story, right? See, this is always important. When you're learning something, always have a rough idea like, okay, what is the theme? What is the overall theme of this thing? And that's important. When you have an overall understanding, right? Okay, this is what is happening, then it becomes easy for you to connect stuff. So if you see in differentiation, right, what we dealt most of the time was things were not constant and things were changing. That could be the slope of a line for a curve. If you see the slope of a tangent was changing. When I said x is equal to t cubed by 3, the velocity was changing with time. There was an acceleration. So we dealt with things, which were changing, right? So all doubts end of the class. So not now, right? So if you have any doubts, you have to stay back end of the class. You can discuss them. So that is one. So now integration, what we do? Yeah. So in integration, we do something else. So let's see this thing. Let me start off with something simple and then we'll try to build it up from there. I think some of you didn't give the test this time, but right. So the next week test is online. So please make sure to give it this time. Some of you have just joined recently and you didn't, maybe were not ready for it. Again, the test was not really that tough. I hope you have seen the paper. Anyway, so what is about this integration? Let me start with a simple example. Let's say if I give you a block, and if someone is applying a force of, let's say, F is equal to 10 newtons, and let's say the block is going from x is equal to 1 to x is equal to 3. And if I ask you find the work done, we know the formula is simply force into displacement. So in this scenario, it was F into x2 minus x1, which is x final minus x initial. That would be 10 into 3 minus 1 and 20 joules. Great. So this was the thing, so we knew how to deal with things when things were constant. Let's say the same thing, if someone had told you this, we have a force which is not constant. This force depends on the x coordinate. F is equal to x, where x is your x coordinate. Meaning, the more you travel along x, the more force you get. Springs generally do this thing. Ever seen a spring? The more you pull it, the more force it applies. It actually becomes more and more difficult to pull the spring. So what if you have a force, same thing, x is equal to 1 to x is equal to 3. And now if I ask you to find the work done, the problem is there is only one formula that I know. So that is the thing. Physics does not create, different formulas for different things. There is always the same formula. Now, if I try to apply the formula, force into displacement, chalo, S ka value, I can still figure it out that I can say it is 3 minus 1. But what about the force? What will you take the forces? Will you take when the see, look at this force here. When x is equal to 1, force is equal to 1. When x is 1.1, force is 1.1. When x is 3, force is 3. So that force is changing continuously. So what value will you take? Will I take the initial value? Will I take the final value? Will I take the average? Or will I take exactly what should I take? So that's the confusion here. Since f is changing continuously, what are we going to take? The more you move, the more force changes, and so we're not sure what to do with this. And we observe in real life, right? There are a lot of things like this where they're changing continuously and your regular formulas stop working. Right? We're not sure what to use. So that is the story there. So then how do we go about it? So then someone said, why not, do it for very small increments? So the idea was this. Again, don't worry too much about this. It's just I'm giving a little background, like how things are working here. So the idea was this. Let's say we take a point x is equal to 1, and we'll take one more point here, which is x is equal to 1.0000000. A very small delta x, right? We are taking a very, very small distance, and then we are going to say, okay, this displacement, right, x2 1.0 is so small, I can approximately say f is 1, right? So we can approximate it. Because you're moving such a small distance, we can say f is almost 1. And then we'll find the small work done here, W1, which is 1 into the displacement is 0.00000. What? That's your displacement. Great. Now, once the block reaches here, then we are going to say, now the force is 1.0000001. And then we are going to say you're going to travel to a point which is 1.00002. So you're getting what we're doing? We are moving it so slowly. Now you're going to write the work done will be 1.0000001 into the displacement will always remain same. You are moving it so slow. Next time, the force will be 1.00002. The displacement will remain same. And I'll keep doing this a lot of pieces. So finally, the last piece would be whatever is this thing, I'll call it maybe n. This would be 2.99999999 into 0.00001. Now, the whole idea is if I add all these things, yeah, I'll still get an error, but I think my work will be almost. This is what actually computers do. A computer does not know how to integrate. It literally takes a very small decimals and then it just multiplies. It kind of works out. But the thing is, if you take so many decimals, right, you do get an error, but the error will occur at 10 or 15 decimals. So for all practical purposes, it works out, right? So this thing still has an error, right? So we have an error, but almost it works, right? This thing is almost true. Got the idea what we did roughly? So this is the background. So someone thought like, okay, why don't we do this? Now let's put it in a more simpler form that Let's do with area. So if you take a y-axis graph and if I give you a straight line. So let's say this is x1, this is x2, and this is y. If I ask you what is the area under the curve, it's straightforward. You will simply say the area of the rectangle will be base into height. That will be y into x2 minus x1. We can simply write this thing as y into delta x. Delta x is the difference between. Great. So I know how to find the area of a rectangle. But then you will come and say, okay, can you find the area under this curve? There. Now we are dead. So this was the whole thing every time, like we pop up some weird equation and say, find area under this. Now, unfortunately, the only formula we know is area of a rectangle. Understand this thing. physics mein everything that you get, right? The formulas and all are always derived for constant stuff. We use our max to figure out how to get this thing. This is x1 and x2. Now, if I try to find the area under this, using the rectangle formula, area is y into delta x. Again, the question comes the same. What is y? We don't know y. Just like we didn't know force in the previous case. We don't know the value of y. So then we come up with an idea. We say, okay, let's do this. Why don't I take a very small piece? This is x1 and this is x2. So let's take a small slice here whose width is delta x. So I get a rectangle. Now, if I try to draw this rectangle, you will see it kind of looks like this. It's not a perfect rectangle though. The width of the rectangle was delta x. Let's say at certain distance here, we can call this function y is equal to f of x, which is the equation of the curve. And let's say this height is yi. And this height of this, not a proper rectangle, is this. And now if I try to use a rectangular formula here, you will observe this black thing which I'm shading here is your error. And the area for this small rectangle, delta AI, the thin rectangle, is given by yi into delta x. But remember, this has error because that's not exactly a rectangle. Then the logic was this. So why don't I just add up all these rectangles? I'll divide this into small, small slices. And if I add all these rectangles, that should give me area under the curve. But yeah, like I said, there is an error. So area under the curve will be sigma. Sigma is a symbol for summation, which is delta AI. You're adding all these things. You end up with, and again, these are from what? X1 to X2. This is just like your for loop. In coding, did you ever do this thing? For loop from 1 is equal to n to 1 to 10. You're doing that summation. Sigma is like a for loop where you're going from 1 to 2. So the meaning of this symbol is you're adding all the rectangles from X1 to X2. That's the meaning of this. So this would turn out to be sigma x1 to x2. This is delta AI is simply yi delta x. Again, don't worry too much about it. I'm just trying to give you a context like what's happening here. Frankly speaking, we really don't need this. I can just give you a formula, we can start doing things, but that won't help if you don't understand why the hell are we doing it. So sigma is your summation there. And what this whole symbol means is we are adding all the areas, all the rectangles from x1 to x2. That's the meaning of x1 and x2. But again, remember, this has error. So you know what we did actually? What we did was this. You took this curve and you broke it into pieces. And when you try to reconstruct it, this is what you did when you took that small, small pieces. This is what you built. You have actually built a lot of small, small rectangles. And then you're calling it, okay, this guy and this guy are same. And you might think like, okay, you know, this is looking weird. You do this every day. You just don't realize it. Ever heard the word analog signal and digital signal? Heard that word term. So what do you guys think about it? Like, you know, ever seen this thing? If you ever try to download music or any file or something, sometimes it'll be written like this, 128 kbps, 320 kbps. Kabhi dekha aisa symbol? At the end of the file name, you will see, you know, there is a 128 kbps and 320 kbps. You know, what is this? So do you know how your mic works? Right now I'm speaking to you, right? How do you think the whole system is working? First thing, when I'm speaking, right, there is a small piezoelectric material, right, that is generating, whenever I talk, the pressure waves, right, generate the electric signals there. Just a second. Yeah. So every time I speak, right, the pressure waves hit the piezoelectric material, that generates signals, you get a voltage signal. So that's fine. We got that. But how do we transmit this? If you tell a computer, let's say this is my audio, okay, when I'm speaking, let's say this is voltage versus time. So when you're speaking, right, this would be your audio signal or something. Now, if you tell a computer, record this, how many points are there on a curve? Infinity. So if you tell it to record everything, it will record infinite points. And infinite points will take how much data? Infinite data. That means you can actually not save everything. So what you tell a computer, okay, don't try to save everything. So this is called an analog signal. So it's basically a continuous signal. So you can simply say signal is present at all times. We tell the computer, okay, do one thing. Why don't you record it at 1 bit per second? So what you tell the computer, every second, just take one sample. So this is what the computer does. So every 1 second, it will take one sample. And when it tries to play it, this is what it does. It will take a sound for 1 second. It will play it for 1 second continuously. So if I say, hello, how are you? And if I record this at 1 bit and if I try to play, it will play like, this is what you hear. Because you just took and then you played it for 1 second. Hello, may L and all went away. O was there. You played that for 1 second. So you'll hear like, that's it. There is no audio, nothing. Everything is garbage. Then you'll say, oh, this is bad. Then you'll say, yeah, why don't you record this at 10 bits per second? So now you're taking every sample, every point 1 second. And now, if you try to play the same thing, it's much better. Still, you will see words are missing, things are a little blurry and all, but you get pretty close to the curve. Did you ever see the numbers in a railway platform? How they write 8 and 7 and all? 7 looks like this, isn't it? 8 looks like this. Ever played a snake game in Nokia Mobile? That's a digital snake. It's all pixelated. If you try to play now a snake game on a latest mobile, right, you have a high pixel density, so you can actually see the curves of the snake. Not exactly curve, because what you're seeing is this. Ask you one simple thing. Do you think this is a curve? You think this is a curve? If I can actually zoom in, at some point you'll start seeing the pixels. You have never seen a curve on a screen in your life. What you're seeing so far, right, was all this. You have simply seen straight lines. The density was so high, our eyes got fooled and we think it is a curve. If I draw a circle, the computer is actually drawing this. Straight lines, all straight lines. You can never see a curve. Anyway, so that's how it is in your life. You have never seen a circle on a computer screen or a TV screen or on any digital thing. Why all that? You have never heard your own voice properly. You know that? Did you ever try this thing? Maybe after the class or tomorrow, take a phone, record your voice and hear it. Right? You will feel like, who the hell is this? Ever heard your own voice recording? And you play that same sound to your mom or your friend and ask them, like, what do you think? And they'll say, yeah, it is you. That is how you talk. Ever thought about it? Why does your recording feel so weird? It really feels like, who the hell is this? Ever noticed it? So what happens is when you're speaking, right, there are two sounds. One sound is going through the air. That's what most people hear. But you also, right, the one of the sound travels through your cheekbones, which is reaches your ear. So your ear actually hears two sounds, one through the air and one through your bones. And sound travels faster in solids. So your ear actually hears two different sounds with a small lag. Now your brain takes both the sounds and does a remix and makes you hear something else, which will sound beautiful though. Imagine brain doesn't do that. Then you know what you'll hear when I say hello, hello, how are you, what are you doing, what are you doing? There'll be two sounds every time. You'll go mad. And that's the reason you must have noticed that. You're sitting with your friend is singing a song, they think like they're singing really well, and you're thinking like, why is this guy howling? Like a wolf or a frog. What the hell is even the friend trying to do exactly? But he thinks or she thinks like, oh, I'm singing so awesome. Yeah, so the brain fools you that way. So yeah, end of the day, this is the story there. So every time when you do analog and digital, you're actually integrating things. This is what you're doing, the whole story I said. So when you say 128 kbps, what you're doing is actually you're taking 128,000 samples per second. So you collect a lot of data, right? So if you say 320 kbps, that is the reason 320 kbps ka file is almost double the size because you take more data. Anyway, that's a little background on that. So whenever you're actually recording your voice and stuff, you are actually integrating. If you actually see, right, the audio recording, which actually happens in the theater, that each song has a size of around 30 to 40 GB when they record it. They compress it down to a normal size and they upload it. But anyway, we humans really can't differentiate between such a high quality and a low quality. It works for us. Anyway, so that is one. Now, coming back to the story, like we still have an error. Remember, we still didn't make it good. So, what if the delta x tends to 0? If you make the delta x tending to 0, that means you're making the rectangle so small, the error suddenly becomes negligible. So, theoretically, you can tend it to 0 and you can make error tending to 0. Now, suddenly the error vanishes, right? So, if delta x tends to 0, you actually get a beautiful curve. You are taking such a small points there, they almost look the same. That steps will start looking like a curve. So it just becomes like a line. So now your formula, area under the curve. This is how you should write it mathematically. Remember, if I put sigma yi delta x, right? x1 to x2. If I just write this, it is wrong. But if I add one word here, limit delta x tends to 0, now suddenly it becomes right. You guys remember this? We did the same thing in differentiation also. If I wrote delta y by delta x, it's wrong. But I put limit delta x tends to 0, suddenly it becomes a slope. Again, don't look at that whole thing and get scared. What it simply means is when you take very small elements, that is delta x tends to 0, this quantity sigma yi delta x represents the area under the curve without any errors. That's the thing. All clear with this. But then again, we are lazy to write this. Who will write such a big term every time? So we said, okay, let's make it look simple. We'll just put a symbol like this, which looks like a snake. It's called an integral symbol, which is y dx. So delta x becomes dx, the sigma, and this everything becomes integral, and the limits will go from x1 to x2. So the meaning of that symbol is simply it means you are adding. So this x1 is called lower limit. That is simply the starting point where you want the area from. Great, this will give you area, but from where to where? X2 is your upper limit. So this symbol sigma is called summation. So when you put sigma, you're adding things. When you put the symbol integral, this is also summation, but you're adding very small things. So that is the whole idea there. So sum of very small terms. Everyone clear with the context? Great. So that's it. So that's the whole story there. So what we did was this. You cannot apply the formula directly, so you broke it down into such a small piece. Now the formula starts working with an error. If you can make that piece very, very, very small, your error suddenly becomes zero and your answer becomes right. So your computers do this every time. They do have errors. Theoretically, you will always have an error, but that error will occur maybe on 10th or 15th decimal. So it really doesn't matter for us in day-to-day life. So perfect. So if you have a curve, just let's write down the important thing. This is the area under the curve. And how we get the formulas and all, we will not see. We will just see some results. Unlike, differentiation, right? Integration formulas are straightforward. We don't have chain rule. We do have a product rule, but we don't use it in physics. So it works out. So that is the area under the curve is integral y dx. And not only here, we use this at different places. Like I said, I showed you area because it was easy for you to understand. What is work? Integral f dx. So the formulas will change like this. If your force is not constant, we have to use the formula integral f dx instead of f into dx. What is displacement? Instead of using velocity into time, we have to use integral v dt if your velocity is changing with time. So integrals will start coming. I'll show you when it comes. That is one. Next thing, if you take an integral function and if you differentiate it, so just try to think about it. When you're adding f of x dx, you're adding stuff, and differentiating, you're breaking it. So you will get the function back. That's one way to remember this. So when an integral is differentiated, we get the function back. Right? So great. So let's see the formulas. Now again, we're not going to ask how did you get the formula and all. So just remember them. So I'll give you a function and we will see what is the formula for this. I'll give you some examples also. The first one and the most important one, this thing comes a lot. 80% of the time, this is what we're going to use. X power n. This is for n not equal to -1. So there is an exception. It doesn't work for n minus 1. So integral x power n dx. So listen carefully. The formula is x power n plus 1 by n plus 1 plus constant. How we got this, don't worry about it. This is the formula there. Now, this is called an indefinite integration. If you observe here, I didn't keep any upper limit. I didn't keep any lower limit. So what you're saying is I got the area, but I don't know I got it from where to where. You're not telling me you want the area from where to where. So there are no upper and lower limits. Since you didn't tell me you want the area from where to where, I will add a constant here. Depending on what is your initial and final value, the constant ka value will keep changing. That's it. That's how you can think of. So if there are no limits, you have to add a word called plus constant here. And this is called as indefinite integration. We will see this a little less. Most of the times we will have limits. But to give you a little context, so listen to this carefully. Remember what I said? If I differentiate the function, means whatever result I get, if I differentiate this, I should get the function back. So look at this. If I take dy dx of x power n plus 1 by n plus 1 plus constant. So if you differentiate this function, x power n plus 1 ka differential is n plus 1 into x power n plus 1 minus 1 by n plus 1. Constant ka differential is 0. You will see, you will get back x power n. There, this is what I was saying. So this is one neat way of remembering it. Like, whatever answer you get, if you differentiate that, you should get this function back again. So in case you don't know this, I think you should note down the formulas. So let me put down the next one. You can note down from here. So listen to this thing. So if you put limits, how will it work? So integral x power n dx, let's say limits are from x1 to x2. This is given by x power n plus 1 by n plus 1. Remember, this does not work for n equal to minus 1. We'll put a straight line here, x1 to x2. The meaning of this is integration is completed. We are yet to substitute the limits. That's the meaning of putting a straight line. Integration is done. We still have to apply limits. This is called a definite integration. Maybe you know the limits. We know from where to where you are asking. So simple thing. If limits are not given, the formula remains the same plus constant add kar lo. If limits are given, then I'll show you what to do. So once we are done this is what you do. Put x2 inside, x2 n plus 1 by n plus 1, meaning this is the area up to x2. Then put x1 inside, x1 by n plus 1 by n plus 1. This is the area up to x1. If I subtract them, I get area between them. That is how you can think of. So this is area up to x2. We don't know from where, like this is area up to x2. This is area up to x1. Now, when you subtract this, you get area between x2 and x1. That's how you can think of. That's how you apply your limits. Let me show you a simple example. Let's say I give you y is equal to x square, and I ask you integral y dx from 1 to 2, or integral x square dx from 1 to 2. Look at the formula, x power n is equal to 2. The formula looks like x power 2 plus 1 by 2 plus 1. Limits will go from 1 to 2. That's how you apply this. I hope everyone is clear so far. Then this would be x cubed by 3. As long as I keep this vertical line, meaning I am at to put the limits. Put the limits, I get 2 cubed by 3. Put the limits 1 cubed by 3. This would give me 7 by 3. But what does this even mean? Let's see it picture wise. I know these are basics, but important. We need to know. So there, this is your parabola. Y is equal to x square. It's called a parabola. Now, understand the meaning of it. You're asking, find me the area under the curve y is equal to x square from 1 to 2. So x is equal to 1 is somewhere here, and x is equal to 2 is somewhere here. And this area between the curve is 7 by 3. There. So till now, we know how to find area for a rectangles. Now you have gained an ability to find area under curves. That's what it actually means. So that's what I'm saying. There is no way you can find area under the curve using your normal techniques, but integration will give you this. Yeah, but frankly speaking, physics, we don't use this for areas exactly. We have much better things. But that is the idea there. All clear with this? Let me give you one more example. If you say integral x cube dx, right? Let's say from minus 2 to minus 3 or something like this. And this would be, again, remember n is equal to 3. This is x power 4 by x power 3 plus 1 by x 3 plus 1. Limits are minus 1 to minus 2. That's x power 4 by 4. Limits are minus 1 to minus 2. Substitute minus 2 there. Minus 2 power 4 by 4. And this is minus 1 power 4 by 4. That would be 2 power 4. Wait, let me just change this thing. Minus 1 and minus 2. I wanted to show you something. This would be minus 1 power 4 by 4 minus 2 power 4 by 4. That would be 1 minus 15 by 4. Why did you get a negative? So if you try to plot the graph, you will see a y is equal to x cube graph will look like this. When x is positive, y is positive. When x is negative, y is negative. This is how a graph of y is equal to x cube looks like. Understand the meaning. You're asking, find the area from x is equal to -1 to x is equal to -2. And this is the area we got. So the negative sign indicates the area was below the axis. Clear with this? So that's the meaning of a negative area there. So this area is -15/4. So simply the negative area indicates it's below the axis. All clear with this? That's your first formula there. Please note it down in case you don't know about this. And this is the most common formula, like comes a lot. Clear? Can I go ahead? Manav? Ananya? Dave? Great. Next one. The second formula. Integral sine ax plus b dx from x1 to x2. This is -1 by a cos ax plus b. Limits will go from x1 to x2. And just try to understand this. If I differentiate this function, cos ka differential minus sine ax plus b, then I have to differentiate the inside one chain rule, I'll get an a outside. So that a and that minus will cancel and you'll get sine ax plus b. So every time you differentiate this result, I will always get this function back. And then how to put the limits? So first put x2. That will be cos ax2 plus b. Then put x1, and we get cos ax1 plus b. You can note down that. Then we have cos ax plus b. Limits are from x1 to x2. This is 1 by a sine ax plus b. Limits x1 to x2. 1 by a sine ax2 plus b minus sine ax1 plus b. Integral a power x dx. x1 to x2. This is 1 by a e power ax. Limits are from x1 to x2. That will be 1 by a e power ax2 minus e power ax1. Integral dx by ax plus b. Maybe I'll write this in the next page, but have a look at this page. Do note down the formulas in case you don't remember them or you don't know about it. How we got the formulas, don't worry about it. Like I said, these are all just mathematical tools. Applications will be something else. So that we will see. That's where we have to focus more. And integration will come literally everywhere. Every chapter you will see integration in one form or another way. Without calculus, right? Differentiation, integration, you won't be able to handle advanced problems. Mains फिर भी थोड़ा चल जाता है, but advanced में literally 30-40% of the paper will involve calculus. We use extensively, and we will see some models today. Like I keep saying, right? The calculus is always not the difficult part. The headache is always converting the verbal problem into an equation. All copied? Great. Next thing. Correct. This one is important, right? Meaning it comes a lot, and people have a little bit of a struggle with this, but quite an important thing. You'll see this mostly in 12th though, but we will see in 11th also. So this is 1 by a ln ax plus b. One by a ln ax2 plus b ln ax1 plus b. I hope everyone knows a bit of a logarithms there. So ln a minus ln b is ln a by b. Now here, if I do this integral dx by x, so see what we did. I wrote a is equal to 1 and b is equal to 0. So dx by dx is simply ln x. That's ln x2 minus ln x1. There, that's it. We have only these 5 formulas. You should know these 5 formulas for integration. So just copy down, na, Anish. That's what I said. Copy it down. You will need them to solve. The problem is you learn somewhere bits and pieces. Don't mix up things. Don't become confident like, oh, mujhe aata hai. Listen, aram se I'm building it, right? So take it from me. I know some of you already know this stuff, but I'm teaching you from scratch, from zero, assuming you know nothing. So trust me on that. So put it down. These things, if you ask me, how did you get this? This is max. So we'll not get into that discussion. Max people will take you, they have 3 months to teach you all this stuff. For now, just put down the formula. So if you see a formula, this is what you use. Done discussion. There's nothing about it. Clear with this. This is your 5th formula. Great. Next thing. We have 2 identities. Actually, there are 3 identities. We don't need the third one. There is a product rule in this thing. Physics may never see it, so you'll not use it. The first one is integral a into f of x dx. If someone didn't copy, please let me know. I'll turn it back. You need to copy them down. We will do some problems. You'll get the hang of it. So that's it. If a is a constant, just push the integral outside. I'll show you some examples. Don't worry. So example, let's say if you have something like 3 into x power 4 dx 0 to 1. So the 3 is a constant, just push it outside. That will be x power 4 dx. Then you have to ask yourself, this formula looks like what? This looks like x power n, where n is equal to 4. This will be 3 into, the formula is x power 4 plus 1 by 4 plus 1. Limits from 0 to 1. That would be 3 power 5, and that would be x power 5, limits 0 to 1. Meaning, unless I don't remove that straight line, meaning the limits are yet to be placed. So this would be put 1, put 0, you can get 3 by 5. It's straightforward. Just remove the 3 and put it there. The second one, integral f of x plus or minus g of x dx. So if you have 2 functions, then you just integrate them separately and add them or subtract them depending on what is given. That's it. We have these 2 identities. I hope you can see a lot of similarities with the differentiation thing. The only thing I'm more concerned, right? People mix up differentiation integration formulas. So just be careful with that. I still remember in my first year of teaching, that is in 2010, in one batch I was teaching integration, one batch I was teaching differentiation. I went to the differentiation batch and I taught integration formulas. After 10 minutes, I realized what I was doing. After that, I said, I'm not going to teach integration and differentiation at the same time. So long back, but happens. People do error, so be careful with that. All copied. So we have 5 formulas to remember and 2 identities. So that's it. If you know this much, mathematically, your integration is good. We don't need more than this. There are things, but we'll see them later on. But this is the basic thing there. Clear? Next thing. Can I go ahead? Ananya, Dhruv, Manav, Shlok, Shrikant, Rohit. Great. Next thing, integration of a vector. So how do you integrate a vector? So if you have a vector A bar, which is ax I cap, ay j cap, plus az k cap. So integral A bar dt. Straightforward. You just integrate ax separately and keep the I cap outside. Integrate ay separately. So each coefficient you integrate them, and the I, j, k will simply remain outside, because remember I, j, k are simply constants. Example, let's say if someone gives you A bar is t I cap plus t cube j cap plus t square j cap and t cube k cap. And they ask you integrate A bar dt from 0 to 1. This would be t dt I cap plus t square dt j cap plus integral t cube dt k cap. If you remember, we did the same thing for differentiation also. You differentiated each one separately and you kept an ijk. So remember, this is t power 1. So t square by 2, t power n plus 1 by n plus 1, 0 to 1, I cap. This is t cube by 3, 0 to 1, j cap. Remember, I'm just using x power n ka formula. T power 4 by 4, 0 to 1, k cap. Now substitute 1, substitute 0. You end up with half I cap, 1 by 3 j cap, and 1 by 4 k cap. Now understand one thing, in the beginning, I taught you integration using area because that is something you already have an idea. It doesn't mean everything should make sense. For example, when we differentiated dx by dt, this is not slope, right? This became velocity. When I said dv by dt, this is not slope, it became acceleration. So they had different meanings. So you can differentiate anything with anything, same way you can integrate anything with anything. So if I integrate velocity into time, what will I get? Displacement. So what is a vector? It depends on what is a vector exactly. All clear with this? Hope everyone has copied things. Soumya, Shriya, Sumana, clear? Great. So now I'll give you a few questions just for the practice. So let's get them done. And if you are able to handle them, then I think your mathematical part is great. And then we'll see some applications. It's a small chapter. Like I said, integration, right? I will teach you again when the actual chapter comes. But the whole point is that if I can give you a little glimpse of it now, when I actually teach you it, mostly we will do it extensively in center of mass karke fifth or sixth chapter. So that by then we have to be ready. Anyway, so let's see this thing. So root x dx from 1 to 2. That you can just solve that. You'll get all numbers only. You can put a number. Okay. This is dx by x power 3 by 2. Integral x square plus 1 whole square dx. Three x square plus 2x dx. Get them in this. If you see, na, G and H are important. These things will come a lot, in a chapter called SHM. Uh, Let's get them. You have the formulas written, so use the formulas. Just try to see and apply them. It is all formula substitution. There's nothing to think. It is all matching. Okay, this formula looks like what? So what formula should I use? Give it a try. I'll show you the first two in a minute. Like you can keep going. Like if you got all of them, then great. Yeah, keep doing it. So you can verify once I write down the answers. Some are difficult to type also. That's okay. Okay, let's see the first two. So integral x dx. So this can be written as x power half dx. This is looking like what? This is looking like x power n. So n ka place mein we have half. So the formula is x power half plus 1 by half plus 1. Limits will go from 1 to 2. So that would be 3 by 2. So that is 2 by 3 x power 3 by 2. Limits will go from 1 to 2. That is 2 by 3. Put 2, we get 2 power 3 by 2 and put 1. That's it. You can leave it like that. That is the answer. There's no need to simplify it further. But what does it even mean? So what does it mean? If I plot this graph, y is equal to root x, so that visualization is important. So this is a graph, y is equal to root x. You have asked me to find the area from x is equal to 1 to x is equal to 2. And this area was this. That's the meaning of it. What about this guy? Same story here. I can send it up. Integral x power minus 3 by 2 dx from 1 to 2. So n ka value is minus 3 by 2. You need to get used to this. And then, yeah, this will be x power minus 3 by 2 plus 1 by minus 3 by 2 plus 1, limits 1 to 2. That would be minus half. So minus 2. And that would be x power minus half. 1 to 2. So that's minus 2 by root x from 1 to 2. That's minus 2. 1 by root 2 minus 1. Multiply 2 inside. You end up with 2 minus root 2. That's your answer. All clear with this? Clear with this? Any doubts on this? Everyone got A and B? Can you go ahead with C and D? Keep going. I'll give you another minute or two, then I'll show you C and D. So please ask me anywhere you're confused. You didn't get like, why did I do this? What is that? Any step, please ask me. You can note down the questions because I'll keep flipping the page. So you might not, in case you're going ahead, you will have to wait. So you can note down the questions if you are able to go ahead. Others, let's do C and D. There is no physics here. There's nothing to think here. You know the formula, it's all max. So yeah, don't worry too much like area and all. Just finish it off. Applications we'll see later on. Shrikant, clear so far? Let's go ahead with C also then. C and D. G and H are good. They keep coming a lot. Okay, Rohit went up to E. Okay, let's see C. So we have integral x square plus 1. Now, remember, there is no formula to integrate this directly. We have to expand this. Remember, there is no chain rule in integration. There's nothing like, function to the power of 2. I will use that formula. There are ways to deal with it, but we don't need in physics. So that I'll be showing you anyway next class in the end. But for now, just expand this x square. This will be x power 4 plus 2x square plus 1. Integration in physics is very cute. It's like a small puppy walking on a road. Differentiation was like a tiger running on a road. Integration and max is like a Godzilla going and destroying everything. It's really mad. You will, when you learn next year, you will tell me. So 0 to 1. So look at that thing. You can just split it open. I'll write down few steps. But later on, you need to learn how to skip steps and put them fast. So x square dx plus 1 dx. So some people might get confused here. Oh, how do I do it for 1 dx? So 1 is nothing but x power 0. That is how you can think of. This is x power 5 by 5. 0 to 1. This is 2x cubed by 3, 0 to 1. So you can write this 1 dx as x power 0. So this will become x power 0 plus 1 by 1. So basically integral dx, you'll get x 0 to 1. So that's it. You substitute here 1 by 5 plus 2 by 3 plus 1. So whatever is that answer. How much is that? 1 by 5 plus 5 by 3. 18, 3 plus 5, 25. 28 by 15. Hope I'm right. Yeah. Oh, what about 3x square plus 2x? I'll send you a sheet on this thing also. So make sure to try this. Anyone has difficulty in integration, you should definitely practice it a bit. Not too tough, but little practice will help you a lot. Because the next chapter after this, when we start kinematics, I'm going to literally use everything that I taught you again. Calculus, differentiation, integration will come. We'll use extensively. So you should be thorough with all this basic stuff. So this is 2 integral x dx. Physics mein, that's a big advantage and a disadvantage. Even when I teach you 15 chapter, I'm going to use all the 14 chapters. So it's an advantage because your entire physics is always in revision. Disadvantage is because you mess up 2 chapters in the middle and the whole thing goes for a toss. So yeah, this would be 3x cubed by 3. This is 2x square by 2. So that will be 3 and 3 will cancel. We get x cubed. So that's 1 cube minus 0. This is 1 square minus 0. That's 2. Please ask me if anyone is confused with any particular steps here. A, B, C, D, hope all are clear. Dave, clear? Dhruv? Dhruv, I can't see you. Camera's gone blank again. Anish? Clear so far? Ananya? Ahana? Clear? Shrikant? Shlok? Shriya? Manav? Prisha? Clear, right? Basic stuff. So yeah. What about this guy? Sin 3x cos 2x. Yeah, these things are. So look at the formula, how this looks. So what is the formula? Integral sin ax plus b dx 0 to pi by 3. So if you look at our formula here, this is minus 1 by a cos ax plus b. You can clearly see in the formula sin 3x. So a ka place mein we have 3 and b ka place mein we have 0. So just substitute there and you're done. So this is cos 3x from 0 to pi by 3. This is minus 1 by 3. If you substitute pi by 3, that becomes cos pi. This will be cos 0. Cos pi is -1, cos 0 is 1, that's 2 by 3. So what did you find exactly? If you plot a sine 3x graph, this looks like this. A sine 3x graph is a sin x graph which is compressed by 3 times horizontally. So this would be, if I put a sine pi by 3, this would be the value here. This would be 2 pi by 3 and so on. So what we found was this. We found this area. That is the meaning of this. So this area was 2 by 3. Same thing with cos 2x. Integral cos dx 0 to pi by 2. Again, remember the formula, a का place में 2 and b का place में 0. The formula for this was 1 by a sine 2x. 1 by sine ax plus b. One by 2 sine 2x. Limits from 0 to pi by 3. Substitute pi by 3, then get sine 2 pi by 3. Sine 0. Sine 2 pi by 3 is sine 120, which is root 3 by 2. And that's 0. Root 3 by 4. Clear with this? Oh, sorry, 0 to pi by 2. I messed up the limits. Then this would be sine pi, which is 0. So this is 0. So why did you get 0 here? Because see, Max does not know that you're calling it area. Max is pure. It simply takes y and delta x and it multiplies. So what you got was this. This is a cos 2x curve. So this was pi by 4 and this was pi by 2. So what Max did for the upper part, y was positive, x was positive. So this area was positive. But for the lower part, x is still positive, but y ka value is negative. So this was negative. So the total area became 0. You're getting why we're getting 0. So the area above was positive, area below was negative. So Max really didn't know what was area and all. So they cancel out. So this was a positive area, this was a negative area, and they're gone. And that's why you got a 0 there. All clear with this? Take a break. Come back by 9:45. We'll continue from here. If someone is done, then great. I'll show you this after the break. So G, H, and I will do in one go. Take a break. Any doubt so far? Anyone not clear with any statements, anything in the limits, integration? You can please ask, or else go get away from the screen for 5-7 minutes and come back by 9:45.
Sir, the answer for E is 2 upon 3.
E is yeah, 2/3.
Thank
Yeah,
you.
yeah, you're right. Chalo, come back in 10 minutes. Okay, let's see the remaining three. Sine square and cos square. Chalo, camps on everyone. Now, there is no direct formula to get sine square x directly. So what we do, we go back to trigonometry. We told you these formulas are quite important. So we can write sine square x as 1 minus cos 2x by 2. Hope you didn't forget this. In case you forgot, it's in basic maths. The very first class, we did this thing. Sine square and cos square. Page 15, basic maths. And then you're done. Now suddenly this formula looks like something which we know already. So half comes out, we have an integral. This would be dx minus integral cos 2x dx. 0 to pi by 2, 0 to pi by 2. This would be half. Integral dx would be x only, 0 to pi by 2. This would be half sine 2x, 0 to pi by 2. This is pi by 2 minus 0. When you substitute pi by 2, you end up with sine pi minus sine 0, which is 0 because sine 180 is 0 and sine 0 is also 0. You end up with pi by 4. Please check. So what did we find here exactly? If you try to plot a sine square x graph, remember there's nothing below the axis. Sine square x will look something like this. And this is how a sine square x graph looks like. What we found is an area from 0 to pi by 2. This area was pi by 4. Now the interesting thing about cos square x, it looks exactly the same except for one change. If I do cos square x is 1 plus cos 2x. This becomes plus, this becomes plus, this becomes plus. The answer remains the same. Now, why did the answer remain the same? Because again, if you look at the graph, you'll understand the reason. If you plot a cos square x graph, it would look like this. It looks like sine square x graph where it got shifted a bit. The areas are the same, isn't it? You found the left half and you found the right half. So the areas are the same. That's the reason the answer will look same. So sine square x and cos square x. So be careful. This is how you do it. You cannot do it directly. We have to convert into 1 plus cos 2x and finish it off. Any doubts on this? Clear? And then one last one. What is this? E power minus 2x. Can you guys do this also? And dx by 2x plus 3, 0 to 1. Integral x plus 1 by x and dx from 1 to 2. So e power minus 2x, this thing looks like 1 by a e power ax, where a ka place mein we have minus 2. So just substitute this 1 by minus 2 e power minus 2x from 0 to 1. So the most common mistake here, people write e power 0 as 0. So be careful, e power 0 is 1. That would be 1 minus 1 by e square into half. Let's finish off J and K. Okay, let's see this thing again. What is the formula for this? If you remember, 1 by A ln AX plus B. So A is 2 and B was 3. So that was the formula there. So 1 by 2 ln 2x plus 3. You should definitely practice this in case you're finding it a little difficult. They're not tough, but yeah, it is new. 2 plus 3 minus ln, if you put 0, you will get 3. This would be half ln 5 minus ln 3. Ln 5 minus ln 3 is ln 5 by 3. But anyone, if you're confused, there is some issue there, please stay back after the class. We can discuss in case you're not clear with this. But I would say practice, and if you're still confused, you can ask me in the next class also. It's not like you have to ask today only. Take out all these problems, do them again. Take a rough paper and just do them again once more. Repeat. Repetition is the key. I'm not saying mug up all the things, but mug up the process. When you know the process, and if something changes in the problem, you'll know how to adjust it. Most people think mugging up is bad. Mugging up is not bad. Remembering things is not bad. If you don't remember things, if you don't have enough knowledge, right, what will you think? You can't think in vacuum. You just can't sit under a tree, meditate, and suddenly you start getting ideas. That doesn't happen. You need to have knowledge to connect things, and you need to remember stuff. Remember, this formula is looking like dx by ax plus b, but I think we wrote this thing, right? This is ln x, basically. 1 to 2. This is 3 by 2 plus ln 2 by 1, which is ln 2. We are done. This much integration you can do. I think you can handle most of the problems. Any doubts on this? Clear? Dave? Dhruv? Dave, clear with this? Manav? Clear? Ananya? Ananya, clear, na? Rohit? Srikanth? Perfect. Let's go ahead. And Radhika, clear so far? You can just say a message or something. Okay. Great. So how do we use this? Now, no one is going to give you a direct integral and say, find this and stuff. Let's see how to use this. Areas and volumes. This is where we extensively use in physics. Again, remember, don't worry too much about this. These things I will teach again later on, right? When we do center of mass chapter, again in rotation, fluid mechanics, electrostatics, magnetism, modern physics, these things will pop up at least 7 to 8 times. They keep coming every time. So the main idea is this. In physics, there are like 6 to 7 shapes. You have an idea how to do them sufficient, but let's see. We will take some basic shapes and we will see how to work around it. Let's take a disk. And listen to this thing. The ideas are important. I want to find the area of the disk. Everyone knows the formula. Great. But how do I use with the integration? Let's say radius r. Again, go back to the story. What was integration in the first place? Integration was to choose such a small element where I can approximate it to be a regular formula and then add up all the things. So whenever you see a disk, keep this in mind. We need to define an element. What is an element? The smallest piece which is required to create a system. So this is what we do. Whenever you see a disk, you choose an element which is a thin ring. That means you can say a disk is made of multiple rings. So this word is important. What is an element for a ring? So element for a disk is a rings. You can actually think of like this. Ever seen an onion? An onion rings, kabhi dekha? So onion is simply nothing but made of multiple rings, isn't it? I hope you're able to get a visualization now. So a disk is nothing but made of multiple rings. Great. So how do we use this? So see. So consider a disk. In the disk at a distance x, consider a thin ring. The ring ka thickness is so small. Let the thickness be dx. Dx means very, very small thing. Consider a thin ring of radius x with thickness dx. Now, if I remove this ring, just remove this ring outside. Take a scissor and cut it. If I cut this ring, this will become a rectangle. Technically, it will become a trapezium like this. Where, if you look at the outer part here, that would be this outer part here, which will be the circumference 2 pi x. And the width here dx would be the thickness dx. Can I say this? This trapezium can be treated to be a thin rectangle. So if you take this ring and open it, you get a rectangle. So this area of this thin ring since it is a small ring, we'll call it dA. Remember, every time you put a d means it is very small. Is length into breadth. The length became 2 pi x and the breadth is 2x dx. Is this logic making sense, everyone? What we did? So the area of a ring is length into breadth. What is the length? The circumference. Breadth is dx. Technically, this is a trapezium. It should not be right. But remember, that is the whole beauty of dx. You are making dx so small that trapezium starts looking like a rectangle. Perfect. Now what do you want to find? We want to find the area of the disk. So just add up all the rings. So area of the disk is summation. Since you're adding small areas, we call it integral area of all the rings. Great. Next thing is the limits. Where are the rings starting from? The rings are starting from the center, x is equal to 0. The outermost ring is x is equal to r. Meaning, if I put x is equal to 0, it's the point in the center. X is equal to r by 4, r by 3, r by 5, so on. If you see, these are all are rings. So when x ka value goes from 0 to r, you're covering all the rings. So we can say here, the rings start from x is equal to 0. To x is equal to r. So that means my limit should be from 0 to r. I hope everyone is getting like how we are using the words there. Now when you integrate this, 2 pi x dx from 0 to r. 2 pi is a constant, push it outside. This is integral x power 1 dx. So this is looking like x power n ka formula, which is x power 1 plus 1, which is x square by 2. Limits 0 to r. Substitute r, substitute 0. This would be pi into r square minus 0 square. This is pi r square. All clear with this? See, we took an approximate element which had an error. When you put dx and you integrated, you actually got a proper area. So theoretically, the trapezium becomes a rectangle because theoretically dx can tend to 0. Real life, you'll always get an error. But are you clear how we use this? This is how we will use in physics. Meaning, I have to show you a few cases. You will encounter them a lot. Like, this is not exactly a disk, but this is a sector. We can see arcs you get, right? We get recently we did it in one chapter also, electrostatics. If you see there was a disk like this, and we had to find something, okay? And look at see how we took an element. We took a ring, sigma into 2 pi x dx. So this is the common thing, that area will always keep popping up, and the integration will come. This is a different story, though. Don't worry about it. But the idea is that the moment you see a disk, you should know, all right, this is a ring. It doesn't stop here. If I take another chapter called viscosity here, look at this thing. So there is a disk which is rotating, and you place it on a floor, and it rotates and happens something. Doesn't matter. See what we did. We said there is an element which is a ring. So this is what I was saying. The moment you see a disk and something is happening with it, doesn't matter what. The idea is this, boss, इसमें element होगा ring. That much you figure it out, right? The problem, you will start, your brain will start working. The biggest problem is people see the question, they read the question, they're unable to connect, like, okay, this is related to what. So that way it helps a lot. Clear with this? You can do this without integration also, actually. Think of like this. So we got an idea. The disk is nothing but made of different rings. So I'm not drawing them very small, but now imagine if I take all these rings and start putting them one after another. So this is the outermost ring, okay? This is the radius r. So the outermost ring will be how much? 2 pi r. Agreed? Now I'll take each ring, I'll start putting them one on top of another. If you take very small rings, you will notice they'll actually all form a triangle. If you take this, is O is the center, O is the center. So what is this height? R. What is area of a triangle? Half base into height. Half into base into height, pi r square. Make sense? That so you can actually make a disk into a triangle and figure out the area also. All clear with this? Great. Now we will do more variety on this next class, but let's see some regular shapes today. Next one. Can you find the volume of a solid sphere? So we have a solid sphere of radius r. So first question, like, how will you choose an element? So in a solid sphere, right, there are two ways you can do this. You can choose an element like thin shells. Unfortunately, I can't draw in 3D, so they will look all the same. These are thin shells, hollow shells. So it's like made of again, like an onion. देखा कभी onion, when you open the upper layer, there's one more layer, and one more layer. So it's like an onion. So it's like layers of onion. Sometimes, right, you can choose elements in really interesting ways. And we will see more on that in the next class. I'll show you some weird ways of choosing elements. But the second way of choosing an element, right, is disks. You can take this and you can consider a solid sphere is nothing but a disk. Thin disks. Both will work. You can choose anything you want. Again, depends on the problem. Sometimes choosing one is better. But I think for now, let's use hollow shells. Disks I'll show you in another way. So you can choose elements as thin disks. So whenever you see a solid sphere, you should remember, boss, I can take this as shells or I can take disks. Now, can you guys find the volume of a solid sphere using this shell elements? Think how will you do? And we know the answer already, 4 by 3 pi r cube. So how will you take these shells and add all of them to get a volume? You got an idea here, right? What did I say again? Consider a thin ring of radius x and thickness dx. So here you will say consider a shell of radius x, thickness dx. Find the volume of the shell, integrate. Give it a try. Take a minute or so. Think whatever you can. I'll show you, then you can verify. Anyone not clear with the question, please ask me. So I gave you a solid sphere of radius r, and you need to find the volume of it using integration by choosing elements as hollow shells, like an onion, layer upon layer, layer upon layer. Another way to choose is a disk. Don't worry about that. We will see disk thing later. Let's see. Same idea. Again, unfortunately, we can't put it in 3D. So it looks like a ring only again. So consider a shell of radius x with a thickness dx. So that is the whole idea. You take such a thin elements, right? You can approximate them. Like consider a thin shell of radius x and the thickness dx. Perfect. So for this thin shell, what is the volume? Remember, volume ka formula is area into thickness. Normally speaking, a shell does not have any volume, but you are taking a shell of small thickness. Volume of the shell is surface area into thickness. What is the surface area of a shell? 4 pi x square. Everyone knows that, right? How to get that surface area, that we'll do in the next class. That's another really good derivation. And what is the thickness? dx. हो गया. मतलब ये thin shell का thing is 4 pi x square dx. Dave, is that making sense? It's like if you take the sheet and make it flat, right? The area would be 4 pi x square. Any doubt so far? Great. हो गया. Then what is the volume of a sphere? Add all the shells. So volume of a sphere is summation of volume of the shells. Again, what are the limits? Your first shell is starting from the center. As x ka value increases, you are getting shells are increasing. See, that is the meaning of limits. You're taking the shells from where to where. This will go from 0 to r. This would be integral 4 pi x square dx. Now again, notice something. Was the integration really tough? 4 pi integral x square dx. This is simply x power n ka integration. This is 4 pi x cube by 3. 0 to r. Substitute r and substitute this 4 by 3 pi r cube. All clear this? Any doubts on this? Clear, na, Dave? Ahana, Karthik, Shlok, Dhruv. Great. So using similar idea, can you find volume of a solid cone? Again, we know the formula. 1 by 3 pi r square h. Again, same thing. How do we choose an element? So for a solid cone, the elements will be thin disks. That's what I said. For disks, we can use it multiple places. Let's see how you handle this. So basically, you cut the cone into thin disks. So you are assembling like this. So disk, disk, disk. When you add all these disks, right? And now it just starts looking like a cone. You're piling up one after another. Take 2-3 minutes. It's again completely fine if you don't get something. So the whole idea is that what I'm trying to show you is the integration is actually the easy part. The headache was always converting into an equation. This is the most extensive use of integration. This is what we actually should learn in physics. We really don't care how that integration formula is coming. Finding areas and volumes. Today we are just doing constant density. Tomorrow, right? What if you get a cone like this or a sphere like this, whose density is changing, meaning the center of the cone has more mass, the outside is less mass. Best example, look at Earth. Earth is a uniform sphere? No, right? Earth ka core has more density. Earth ka crust has less density. So if I ask you find the density of the or volume or mass of the Earth, can you directly say rho into 4 by 3 pi r cube? Because rho is not constant. You cannot do that. So yeah, so things are like that. We will see that in the next class. So, but for today, let's play with constant stuff. How do we find the volume of a solid cone? Anyone confused with anything? You're not convinced, not clear, please ask. Why will the radius decrease by 1/3 every time? That depends on the theta, na, Ananya? If this was theta, this was r and h, so tan theta r by h है ना? वो 1/3 होने का कोई जरूरत नहीं, isn't it? Should I help you choosing an element? See, this is how you start. Starting is always the main thing. How do you start? So start like this. Let's say at a height y from the top. So we are taking y from the top. So when I do that, remember, matlab ye coordinate y is 0, you're starting from the top. And at this point, y is equal to h because the total height is h, isn't it? So you always have to start from somewhere in the middle, right? At a y from the top, consider a thin disk whose radius is x. Yeah, you can choose different variables. I'm just keeping x and y because we are comfortable with it. Are you getting what I did here? मतलब actually क्या हुआ पता है? I chose the down as positive y and this as x-axis. Are you clear? Now, if that is not looking good to you, then I could have just reversed the cone, isn't it? I would still get the same thing. It doesn't matter. Up and down is same thing. Great. And what about the thickness now? Now, this is important. Whenever you take thickness or anything, it should be always, if y is coming down, the thickness also should be dy. It's like this. So take a disk of thickness dy and radius x. Maybe let me draw it like this. Consider a disk like this. Yeah, I know it looks like hollow, but it is not. I'm not shaded inside. I'll just leave it like that. There. So that's like a disk of thickness x. Consider a thin disk at a depth y from top. Of thickness dy. Why not dx? Understand the logic. You're coming from straight down, right? So y ka chota piece is dy, na? You can't take dx. Dx is horizontal. So when you're taking thickness, so along y, it should be dy. Along x, it should be dx. You can't take x and y mixed up. So just be careful with that. So along y-axis, we take small dy. Perfect. So there we got a disk. Again, remember it. If you take a very big piece now, it won't look like a disk. It will look something like this, a trapezium kind of thing. Perfect. So this was x, and this was your dy. Now, doesn't this look like a cylinder? If you actually make it very small, you will notice this guy actually looks like a cylinder. It looks like this, whose radius is x and thickness is dy. This looks like a cylinder. That's the whole idea there. Take such a small piece, you can make it a cylinder. Perfect. So what is the volume of this thin disk? The volume of the thin disk is pi into x square area into dy. Pi r square into height. Everyone clear with that? Great. Next thing, this angle is theta. Let's find that relation also. I know it is little work, but yeah, you should definitely go through this. So theta, this was r and this was h. So from here we know tan theta is r by h. But we also know from this equation here, tan theta is also x by y. Agreed? Because the theta will always remain same. So from here, I know x ka value. X is equal to r into y by h. Take this and substitute here. This is pi into r square by h square into y square dy. There. I have got the entire thing in one single variable. The volume of a disk is pi r square by h square y square dy. Any doubt so far? Dhruv, your cam is blank. Can't see you. It's been like that for some time. Do something about it. Not sure what happens to your cam every time. Great. हो गया ना अभी. What do you want? You want to find volume of a cone. So volume of a cone is the integral volume of all the disks. Now, again, be careful. What are the limits? Ask yourself. You took y from the top, matlab this is y0, this is y something, y. So as you keep coming down, these are all the disks. So the disks are starting from 0 and the disks are ending at h. So the limits will go from 0 to h. And this would be pi r square by h square integral y square dy. This is from 0 to h. Again, the integration is the easiest part. This thing looks like x power n ka integration. So that would be y cubed by 3, 0 to h. Substitute h there. You end up with 1 by 3 pi r square h. All sure with this? So the biggest thing is that only. Can you see all the story? Take a small disk, take a thickness, take a volume. This was always the headache. Once you got this, the integration part is easy. Any doubts on the steps? Please ask me. All got how to choose our disks? So you can see, right? Each shape has a different element. If you're taking a disk, the element is a ring. If you're taking a solid sphere, you can take a hollow shell or you can take a disk. For a solid sphere, element disks you can do, but it actually becomes complex. We will see some later on. If you take a cone, then we take a disk. Any doubt so far? Shrikant, clear? Karthik? Ananya? Ahana? Now, using this, you guys do this. We have a paraboloid. This shape is called a paraboloid. How is the shape? Did you ever eat a sweet potato? If you ever take a sweet potato and boil it, and if you break it into two pieces, ऐसा ही दिखेगा ना? Can you imagine it now? So if you take a boiled sweet potato and break it into two pieces, this is how it looks. This is called a paraboloid. See, the moment I said paraboloid, people are like, what the hell? And they said sweet potato, you're like, huh. That is one thing I noticed. If you can explain something in terms of food, people will understand anything. So this is x and y. So this curve equation is y is equal to h square, h by r square into x square. So basically, this is your coordinate x comma y. That's the equation of the paraboloid. So meaning on this paraboloid, if you take any disk, the relation between the y coordinate and the x coordinate is this. Hope that is understood. So that is the meaning of equation of the curve. So this paraboloid ka height is h and the radius is r. This is an important shape. We are going to encounter this later on. This is how it would look. Can you visualize that? That's a much better picture in 3D. You know where you get the shape? If you take water in a bucket and if you spin it, or if you take a water in a glass and take a spoon and rotate it. Did you ever see you get a bowl shape? That shape is called a paraboloid. And this, right, you will encounter later on. Why bola? See, what I'm teaching you, they won't ask directly like this. Questions will be framed like this. So there was a question like this thick. So there was a water in a cylinder called tank, and someone started rotating it, and bowl now water became like this. This shape of the water is called a paraboloid. So we get a shape like this. And the question was this only: find the height of the water, and then we actually use, see, refer basic calculus. So we're going to use it later on. So that result we are doing now. So I need you to find the volume of this paraboloid. You get a pretty good result to remember. And also, it's like how to choose an element. Can someone tell me how to choose an element? That's the first thing. What to choose an element. If you figure that out, then you can go ahead. Do you think I should take... See, it is a 3D shape, okay? If you take for a 3D shape, you should take a 2D element. For 2D shape, you should take a 1D element. You're getting it's always one element lesser, one dimension less. So if you want to find volume, you should take a 2D element. So what will I take? Can I take hollow shells? Doesn't make sense, right? So I should take discs, na? Doesn't it give you the vibes of a cone? But cone may it was straight line, here it is a curve. That's the only difference. You will take elements as discs. Try. I'll give 2-3 minutes. Again, when you see something new question or something, right? Remember step 1, never panic. The moment you panic, everything will start looking weird. Even 2 plus 2 will look like 22. So that is step 1 in any solving problem. And the more weird the question is, you should be more happy. Because 99% of people are going to get scared and run away from the question. And this is something we have noticed over the time, I have seen it. Advanced may, right? Whenever they ask some really weird question, right? People will read the question and get scared and run away. The more weird the question, the more easy to solve. So you need to keep yourself calm and see one thing. If it is really tough, then it is tough for everyone, right? You should put so much work and you should develop that kind of, confidence. I used to be really confident like that. Like physics, I used to feel like this, if I didn't get 2-3 questions, what I used to think? If I am not getting questions in physics, that means in India, 99% people don't get it anyways. So let me focus on the easy questions and moderate questions and do it. That used to be the confidence and arrogance in physics. Maths also I used to have confidence. If I'm not getting questions, I said, ये तो obvious है, मुझे तो आना ही वाला नहीं था anyway. My maths was so bad. If I don't get questions, I was fine. If I get questions, I used to get scared. Maybe I'm doing mistakes. See, that is also confidence. So yeah, let's get this answer. So what is the volume of this sweet potato? Paraboloid. That's the name of this shape officially. Now you want a better picture? I'll show you one more picture. This is the water in a container. Someone got something. Right, Anish, you got it. We have one answer. Others try. Who else got it? Nere Karthik, that is wrong. Okay, let me show you the element. See whether you got the element. So this is the paraboloid. Again, in case you're finding it a little weird and tough, it's supposed to be that way. Don't worry about it. Right? Just think of like, okay, if this comes like this, I should do it like this. So you're learning it. It's not like every time you should get an answer or something. If you got it, great. If you don't get it, that's also fine. Right, Ahana, you got it. Sir, but what about others are getting, I'm not getting? I'll tell you one thing. Don't compare with others. This is your own journey. You focus on yourself. Comparing with others, you will make your life miserable because there'll be always someone better than you in something, in your life. So trust me on this thing. This is something I have seen. As long as you focus on yourself and you keep growing, you will beat the exam. The moment you start focusing on others, it's just a waste of time. So how do you do this? So consider a thin disk somewhere here. See, always you have to start somewhere in the middle. That's a thin disk at a height y, and this is your x coordinate. And let this thickness be dy. So your thin disk will look like this. And the advantage is this, because the disk is so thin, whether this is a curve or this is a straight line, it doesn't matter. I will treat this like a cylinder. Isn't that the story? The moment you say thin disk, I really don't care what is the shape exactly. I will always consider it to be a cylinder. So the volume of this thin disk, let's call it dV, is pi into x square into dy. And it is given y is equal to, what is this equation? H by r square x square. Great. So take x square from here and dump it here. So this will be pi. X square will be r square y by h dy. Oh yeah, that's the volume of a thin disk. So the volume of a paraboloid is integral dV, which is pi into r square by h. All this is constant, integral y dy. Y is nothing but the height. When you're here, y is 0, and when you're here, y is equal to h. Limits will go from 0 to h. This would be pi r square by h. That is y square by 2. Limits will be 0 to h. That would be pi r square by 2h, and that would be h square. You get pi r square by 2h. That's your volume. Clear with this? So what's so great about this result? If you notice this carefully, you will notice something. If you consider a cylinder of radius r and height h, and inside the cylinder, if you put this sweet potato, it would look something like this, isn't it? And we proved for this paraboloid, the volume is exactly half of the cylinder, isn't it? Pi r square h is the volume of a cylinder, and the paraboloid is half of it. So volume of the paraboloid. So it's easy to remember that way. Is half of the volume of the cylinder it is enclosed. It should be completely placed inside a cylinder from top to bottom. Volume of the cylinder which encloses it. That's half into pi r square h. Meaning you can even say like this then. That means the remaining half of the cylinder which is empty is also pi r square h. So this and the green part, they have same volume. All clear with this? Now, tomorrow what they will do, instead of this shape, they will say something else. They will say this is y is equal to x power 4. You can still do this, right? The story is always the same. You just keep changing that x and y. There, this is how you can play around. All clear with this? So see how we started today. We started the whole game with finding area of a rectangle. By end of the class, you can find volume of a sweet potato. So yeah, so like I said, integration is just a tool. The whole point is how do we apply this? And this is what we are more interested in. The integration is fine. You can handle that. But these questions, right, please make sure to go through them. I'll send you some practice questions also. You can try that also. But next class, I'll teach you even more variations. I think that will make things more clear. But I think for today, try to practice in case you found the formulas difficult, these integrations and all, please make sure to go through them again. Right? These 9-10 questions. Okay, with that, we'll wrap up for the day. We'll see you again on Wednesday. We'll continue from here. So, same time. So, any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you guys again Wednesday. So, take care, stay safe.